video will explain how to do truth trees in the Predicate Logic software. It's going to be very familiar to you from having done it in the propositional logic software. There's just a couple of new rules, couple of new things to keep in mind. Okay, so we're going to do, so as with the propositional logic software, we're going to start with the symbolization. So we're going to start on the symbolization page. And then it will take us, once we've completed the symbolization, it'll give us the option of going to the truth tree page, and we'll get a truth tree with our premise and our conclusion already filled in. Okay, so I'm going to do exercise 2A from chapter 8. So that argument says, someone says our website is ugly. Therefore, everyone says that. So this one is, there exists an X such that X says our website is ugly. So exists an X is the hashtag. And then we need capital SX. And we don't need parentheses on that one because it's just one predicate. So in fact, what happens if we put punctuation in? I don't know how Pospesel feels about that. No, he doesn't like that. I don't really like that either. I would probably not mark you wrong because it's not ambiguous or anything. It's just a little strange and it's unnecessary. Okay. Therefore, everyone says that. So therefore, for every X, X says our website is ugly. Okay. So now we have the option of going to truth trees or to counterexamples. Interesting, it didn't give us an option of going to proofs. This argument is invalid, so we don't want to go to proofs, but it's interesting it didn't even give us that option. Okay, so truth trees, it's basically the same message as with the other one. Okay, so as with the propositional logic software, right, we've got these yellow arrows that tell us what statement we're going to be decomposing first. We can tab to get to a different one if we don't like that one, but it generally, as with the propositional logic software, it generally makes good choices for you, so you should probably just go with it. Okay, so we want to, again, we're going to click on the red arrow, and we'll basically just click on it as many times as we need to get it the right way. It's going to just cycle through the rules. So there's only 4 rules. There's existential right, existential left, universal right, universal left. And then, of course, there are all the propositional logic rules, which won't come into play in this example. So we'll do the premise first, existential. So that's existential left. Sorry, I have trouble with my left and my right. Okay, so it wants to know what letter we want to instantiate it to. The restriction on existential left is that it must be a letter that is new to the proof. So if for some reason there was, let's say, MA as a premise, we couldn't use A here, but there isn't, so we can go ahead and use A. So I would just go ahead and use A, but if you don't want to use A, change it. We can use B just to be fun. Okay. All right, so then now it's moved on to the next premise. So we're going to instantiate that. Now we don't want it on that side because we actually want it on the same side that we're on. You're always going to instantiate on the same side that you're on, and then you move things around. But instantiation is always going to happen on the same side of the tree that the statement is originally on. So we could do this with a B, or we could pick a different letter. Now, this, so universal right also has a restriction that the letter must be new to the proof. So we actually do need to change it in this case. So we need to pick a different letter. So we'll pick A this time. Okay. And now we have instantiated everything. And so we check and see, do we have the same formula on both sides of the tree? And the answer is no, because we have SB on one side and SA on the other, and those are not the same formula. So this remains open. So we have at the end of the tree, we have different options. We have, so you could click it explicitly open or closed, or I seem to remember, I'm not getting that option now, and I don't know if it's because this tree is not very complex, but there is, so there's the plus principle, right? That says that if an open branch contains a quantification marked with a plus, which doesn't come into play here because nothing's marked with a plus, that has not yet been instantiated to some constant that occurs on that branch, then the quantification must be instantiated to that constant before the branch may be marked open. If you've done this a number of times, there is a point in which you can stop. And I think it's like 3 times. I think he gets into that later, not in that first truth tree chapter, but maybe later on when we talk about it, or just it comes up. There is a point where you can stop, and then you can get like an infinity thing that just says basically, look, no matter how many times I do this, I'm not going to get a different answer. So there are cases where you'll get sort of an infinity thing that just says, look, I could keep doing this forever, because that can happen with sufficiently complex predicate arguments. I'm probably not going to give you anything that complex, so it's probably not going to come into play for you. Okay, so I think I'm done with this tree, so let's check and see. It says, yes, you've correctly completed your tree. What does it show? So since the only branch remained open, it shows invalidity, right? There is at least one open branch. In this case, there's only one branch. Oh, and now it gave me sounds. It said, excellent. I don't know why it gave me sounds now and wasn't giving me sounds earlier, but in earlier videos, I haven't changed anything. Let's do one more. Let's do one of the practice problems, because I want to do one that's a little bit more complicated, maybe, just so you can see. Okay. So let's do this one. Okay, so we're going to start with the existential statement, start with instantiating. And I think that's, in general, that's a good place to start. Just start instantiating. So I can pick any letter I like, except I can't pick M. I'm going to actually pick M so that you can see how he yells at you. We're going to pick M. And also you can see what goes wrong, maybe. Okay, so then we can, now it's just propositional logic, right? So we're going to decompose FM and KM, and that's actually how you do it. So our first try was right. Now we need to do it not FM. So that goes there, right? Because if not FM is true, then FM is false. And now we have FM and FM on either side of the tree, right? So actually the tree closes. We don't need to do not KM. It really wanted to do it. All right, it really wants to do it, so I'm just going to let it do it. So that closes, right? Because I've done KM. Yeah. Now, this is not going to be correct because I broke the restriction on existential left. So it's going to yell at me, right? So here it says, aha, the individual constant introduced must be new to the branch. So, and it has this red X that tells me I went wrong there. So I'm just going to snip and we'll start over. So instead of using M, we'll use N. That's a good letter. Okay. So for some reason it wants to do not KM first. Fine. Okay. So now the tree doesn't close, right? So that's why the restriction is there on existential left, because otherwise the reason for the restriction is you don't want to, right? The letter has to be arbitrary, right? Because this is just saying there is something that exists that has these qualities. We don't know what that thing is, but we need to make sure that it needs to be a new letter because it needs to be something arbitrary. And the conclusion has to follow from that arbitrariness, not from some accidental feature that we accidentally picked M. And there also happens to be something in the world that we know about that starts with M that has that quality, right? So we don't want to, so say Mary has that quality. Well, we don't know for sure that just because actually we know that she doesn't have that quality. Sorry, I take that back. We know she doesn't have that quality. And so, but whether we knew it or not, right, we don't want to make any conclusions about this statement that there exists an X that has both these qualities. We don't want to arbitrarily say it's Mary that has those qualities because we don't know that. We don't know that Mary has both these qualities. I mean, as it turns out, we know that she doesn't because she doesn't have one of them. But anyway, that's the point. So here, now we want to say that this is open. And now we check our tree and it says, yes, you're correct. So this shows invalidity. Cool. All right, so that's how you do truth trees. It's basically the same except for the instantiation. And you just have to keep in mind the restrictions and then also the plus principle. But it will talk you through that. If you haven't instantiated enough, Pospesel will let you know. In fact, let's do one that will involve that. So let's pick kind of an ugly one. Well, ugly isn't necessarily going to do the job. Let me just think about this. Well, let's do one with universals so that you get an idea of how to do this anyway. Okay, so you'll notice with this unit one, it's starting with the conclusion. And the reason why is because there's a restriction on the conclusion. There isn't on the premises. So universal right has a restriction, right? That the variable introduced must be new to the proof. Or new to the tree, sorry. That a similar restriction exists with proof. So that's why I said that, sorry. So it wants you to start with that. But suppose we said, I want to start with the premises. So you can do that. It's going to make things more complicated, but we can do that. So we just tab and we can go to the premises. So let's instantiate this. I'm going to go back up to A. I always use A and then I use B and so forth. Okay, so all is well so far. And I'm like, no, I want to do the premises first. Stop. Why won't you go to the premises? All right, it really doesn't want me to. Okay, now it's letting me move. Okay, so I want to do premise too. All right, so I'm going to instantiate this. I can use the same letter, so I'm going to. Whenever you can use the same letter, do, because it's, well, you'll see. You'll get to see why that's important. Okay, so now I need to instantiate the conclusion. So I'm going to instantiate it on this side. And now I need to use a different letter because I've already used A. So, okay, I need to use B. So there I go. Okay, so now it's suggesting that now it's just propositional logic stuff. So it's suggesting I do the conclusion first. And so I'm going to do that. So so this statement is false, right? Whenever the antecedent is true and the conclusion is consequent is false. So that's how I do that. So now I'm going to do this statement. So I want the antecedent to be false and the consequent true. Oops, why did it? I don't know why it's doing that. I didn't right click it, but it seemed to think I did. Okay. All right, so there we go. Now I check to see, does it close off? And no, it doesn't, because I've got CB on one side of the tree and CA on the other. So that doesn't help. That doesn't close because they're not the same formula. So now I have to do EA and DA. Why is it keep trying to finish off my tree? I'm not, it's probably how I'm pressing. Sorry, I'm not very good at using this computer. Okay. All right, so now the question is, does this close? No, because they're all different letters. Okay, so I've taken everything apart, right? Now, notice it's going up and it's pointing at that premise again. That's because it wants me to do it again because of the plus principle. There are letters that appear in my tree that I have not instantiated this formula to, right? So if I try to say, okay, this is open. These are all open. I'm done, but these are all open. Come on. Oops. I'm trying to close this off. Now, if I check it, it will tell me that I've violated. Okay, it doesn't tell me. It doesn't clearly tell me that I violated the plus principle. It just says I'm not done yet. I wish it said something like, you know, there's a formula marked with a plus or something like that that is not instantiated to every constant that appears on the branch. I wish it said something like that, but it doesn't. All right, it's saying, so how do I, well, I could just undo things. Okay, all right, so I need to instantiate this formula on every open branch. This is going to get really ugly. I'm gonna just start over. Right? This will be so much simpler if I just had not done the premises first. If I had followed Pospesel's advice, the software's advice, and done the conclusion first. So you should always do things that get marked with a check first. I actually want to undo one more step. Okay, so let's do C. Let's do for all x, if cx, then ex. Okay, happy days. Now, it wants me to do this formula first. I could do that because it's not going to branch, but I really like to instantiate all of my formulas first. So I'm just going to do it that way. I can use the same letter. It's fine now. It really wants me to do that one. There we go. Okay, now I've instantiated everything. That's just how I like to do it. Okay, now it wants me to do CA arrow EA. I'm good with it now. So, oops, wait, too fast. Okay, I needed to click here. Okay, that's where we wanted. So now it wants me to do EA arrow DA next. And is that a good choice? That's not a good choice. I don't like that choice. I'll show you why. I'm going to do it and I'll show you why. Wait, what are you doing? Okay. All right, so that turns out like this. This doesn't close. Nothing closes. Right? We got EA on the same side, and here we have DA, and DA doesn't appear anywhere. So nothing closes. So this is a case where I don't think the software made good choices. I want to do CA arrow DA first, because I have CA and CA on different sides of the tree. So this side closes. Oops. If I had a mouse, this would be easier. But I don't. Oh, stop that. Okay. It's like I can do the star when I'm not trying to, and then when I'm trying to, it won't. Stop that. Ah. I'm going to try one more time, and if it doesn't, I'm just going to go with it. All right, I'm just going to go with it. This really should close off, and I could be done with that, but it's just being difficult. Okay, so it closes off. No, what? So now it wants to instantiate again. It doesn't need to. Stop that. Sorry, I'm not really selling this software right this minute, am I? As I said, it would be easier with a mouse. And I don't know why it's not responding to my right click thing. All right. I'm just going to stop here because it's just too frustrating. This branch closes. This branch also closes because of the CA on either side. So even though there's no DA anywhere up this branch, it doesn't matter because this CA closes it off. Here we have EA, but they're both on the same side of the tree. So this would be open. And likewise, this DA, they're on the same side of the tree. So this would be open. So this tree would have 2 closed branches and 2 open branches. And if it says it's not complete, it's like, yeah, I know, I tried. Try one more time. Like, it doesn't need to be instantiated again. That is not what needs to happen here, Pospesel. All right, we're done. May you have better luck.